We're just going to cover today. Just going to cover metric prefixes and metric units that are going to be used in the course of your study here. So some of this will probably be a review for you if you've had science classes in the past. Typically, science classes use metric units and metric prefixes. We'll first start with the prefixes. All right, we'll start with the small ones. Deci, 1/10. And to the -1. You might have heard deci used in biology class. Typically, blood, I think, is measured in deciliters, or 1/10 of a liter. Yeah, deci is the 1/10. Centi is 1/100th, 10 to the -2. I'm sure you've all heard centimeter before, so that's 1/100th of a meter. Then there's milli. One thousandth of a unit, 10 to the -3. You've heard of millimeters before. In electrical and computer engineering, you'll run into millivolts and milliamps. So you'll see it there. It's 1/1000th. Then there's the micro. Jumps a little bit. One millionth, or 10 to the -6th. For very small amounts of current, you might run into microamps. If a processor is in sleep mode, it might use only a few microamps while it's in that sleep mode. Next one, nanometer, or nano. Is 1/100000th. 10 to the -9. As I let slip, one unit you might run into is nanometers. That's the measurement used to measure the actual circuits in an integrated circuit. One on a scale of billionths of a meter. Nanoseconds are also used in electronics as in the propagation delay. When we'll discuss what the propagation delay actually is a little bit later, but between event 1 happening and the next event happening is measured in nanoseconds often. And then the big one, or the really little one, the pico. 1/10000000th. Yeah. 10 to the -12. Some units are so big, sometimes you need to cut them down to really small scale. That is, will discuss more what it is, but the farad is a very large unit of capacitance, and you will find capacitors rated in the picofarad range. So really, really small amount of capacitance. They go smaller, but for practical purposes, these are the only ones these are the ones that you're going to really need to know in most engineering applications on the small scale. For the larger scale, the kilo is times 1,000, or 10 to the third. There are prefixes for tenth and for tens and hundreds. I've just never seen them used in a practical application. Deca, the unit for 10 times, is used. You might have heard the term decaliter in the movie Dune. That is tens of liters. But that's the only time outside of a textbook and reference type of situation that I've heard deca used as a prefix anywhere. So not really. I don't even. I think it's hecta or hecto is 100. Never heard that used ever in reference to a unit. So we'll start off with kilo as far as the larger numbers. Then there's mega, which is times 1,000,000. Or 10 to the 6th. Let's see here. What example do I have of that? Megaton, the rating of a atomic bomb blast, megatons of TNT equivalent. That's millions of tons of TNT equivalent for a megaton explosion. Giga times 1,000,000,000. It's 10 to the 9th. Let's see. Anybody ever see the Back to the Future movies? 1.21 gigawatts. He says gigawatts, but it's pronounced gigawatts. Kind of a little joke that he doesn't pronounce it right. But that's billions of watts. 1.21 billion watts of power. Then there's tera. Or 10 to the 12th. Tera, you probably have a terabyte hard drive in your laptop or desktop. That seems to be a pretty standard size of a hard drive nowadays, or solid state drive as they're properly called. Yeah, it's a terabyte is a trillion bytes. And then there's peta times 1 quadrillion. Yeah, 10 to the 15th power. For supercomputers, the storage capacity is measured in petabytes or quadrillions of bytes. Processing power is also expressed in petaflops. Flops stands for floating point operations per second. So how many calculations can it do in 1 second? Quadrillions of calculations in 1 second. So there's larger ones like exa, and I think the next one is exa, which is pentillion byte, a pentillion. That's used sometimes in astronomical measurements, exameters, as opposed to light years. But for engineering, most electrical and computer engineering applications, these 5 are sufficient to know. What those units that you're going to be using, though, are, we already talked about volts, or V, for potential difference. And amps, or amperes, which is big A, and that is current. We talked about power, which is in watts. So that would be W for power. In resistance, we talked about ohms, which are OHMS. And that is represented by a omega, a Greek omega symbol. That's resistance. Let's see here. Oh, I mentioned a little bit ago, farads is capacitance. That's a F. And for inductors, inductance is a type of component that we'll get to a little bit later in the course, is measured in henries, H, and that's inductance. And the last common one that you'll run into is hertz. Not a rental car, but a frequency. That's Hz, big H, little z. That's frequency. And all of these can be used with those prefixes that we covered just before. But those are the primary units that you'll be using in the engineering curriculum. Other than, of course, seconds, temperature is in degrees, typically degrees Celsius, in engineering for engineering purposes. I can't think of, and standard distance is like the meter. Yeah. Well, meter is little m distance. Let's squeeze in a second here, which is little s time. Yeah. So yeah, that's that about wraps up the units. Not a whole lot of them. There's a lot of metric units around for all kinds of different things, but for electrical and computer engineering, these are the primary ones. Next session, Wednesday, we will have a, yes, capacitance, Farade's capacitance. I kind of scribbled it. Yeah. Wednesday, we will have a quiz on the material so far. So that will be basic electricity and prefixes and units. So be ready for that. It is open note, so keep your notes handy. No, not open computer. And like I said, very brief lecture today. So have a good day. See you on Wednesday.